Ah, yes. Today we are back to my favorite topic. And once again, we are going to be taking a day and working on word problems once again. To repeat myself, I've said this before and I'll say it many, many times. What is the point of mathematics if you cannot solve problems? And I want you to be able to solve problems. I want you to be able to take what we have learned in this course and be able to look at a situation, translate it to algebra, and then be able to solve the problem. I'm going to go through these problems. These are significantly more difficult than the ones we did the last time. I'm going to go through these problems and set up an equation for each problem, assuming that we all know how to solve equations. Solving the equation is not the difficult part. The hardest part is always taking your time, reading very carefully, and trying to analyze the problem and figure out how you can set it up using algebra, okay? And then solve it. Most of these are going to be tricky. Like, for instance, when the last time we started doing the word problems, I said you should always try to do it mentally first. And I still, to a point, agree that you should do that. But these will be, in many cases, much more difficult for you just to look at it and quickly know how to do it mentally. All right? So we're going to talk about the setups here. There's many, many different techniques I can show you for these problems. I'll try to give you the most important ones. Number one, Raheem is trying to lose weight. He currently weighs 185 pounds and would like to lose 159. He'd like to lose 15% of this, pardon me. I've got it cut off on the other side over there. He'd like to lose 15% of this. Now, when you are doing a percentage problem, and for instance, quite a few of the first ones here are percent problems. The general rule for percents is a rate of increase or decrease. So the percentage is your rate of increase or decrease times whatever the average or the normal is. Okay? Goes in the middle blank. And the third blank is the associated increase or decrease that you have a percentage dealing with. Okay, now there's a couple of other hints. This is almost always the bigger number. Like if you're not sure where to put a number, okay, when you're setting these problems up, this one is almost always the bigger. Okay? This is the smaller. If this works out to be bigger than this, then you know your percentage is more than 100%. Okay, so most of the time, that is the bigger number. If you can remember those three blanks, rate of increase or decrease, average or normal, increase or decrease, you can do any of the percent problems whatsoever. Let's get started. Number one, three blanks. I'm going to be looking for these on your homework paper. Ryan's trying to lose weight. He currently weighs 185 pounds. Isn't that his average or normal weight? 185. He'd like to lose 15% of this. That's the rate of decrease. The beauty of this technique is it tells you what to do. It tells you to multiply these two things. Now, 15% is 0.15. Okay, you got to change it to a decimal or a fraction. You can't deal with a percent. So I have 0.15, and I'm going to simply multiply times that to get the actual decrease in his weight. Now, so anyway, let's find the projected weight loss. So I'm just going to work this one out. 0.15 times 185, I get 27.75 pounds. That is his decrease in weight. That's what he's trying to lose. To find his new weight, you would have to subtract that from 185. Number two, three blanks. Big Mac was priced at 49 cents in 1968 and $1.25 in 1980. Find the percentage increase. Now, this we don't know, the rate of increase. The normal price of the Big Mac, we're assuming we're going back in time and the change was to 1980. So this is the normal price, 0.49, and the $1.25 goes over here. Now, you know how I said that this middle number is usually the bigger number? Notice it is not here, and that means your percentage is going to be more than 100%. Can you multiply these two things? No, you can't. You're missing a number. This is like an equation. 0.49 times x is $1.25. You've got to divide 1.25 divided by 0.49, and I get 2.55, which is 255%. The price of the Big Mac went up well over twice, right? Okay, this percentage formula works beautifully. Number 3, 3 blanks. 25-pound bag of dog food had sales tax applied to it. We know sales tax in Pennsylvania is 6%. Find a normal or regular price of the dog food. So the normal or regular price of the dog food, we have no idea. We know that the sales tax in PA is 6%, and we know the sales tax was 72 cents. Isn't that the increase in price? When you buy a bag of dog food, you take it up to the cashier, it's a little bit more expensive than what it said on the shelf due to the sales tax, 0.72. Can you multiply those two numbers? No, it's like an equation, 0.06 times x. You must divide 0.72 divided by 0.06. Number 4, another percentage problem. Just let me go on my soapbox here just for a second. When you leave this class, you may never take another math course in your life, okay? So this might be the last time you get to think about percent problems, but you will be surrounded by percent situations for the rest of your life. You invest money, you're going to earn a percentage. You have to pay taxes, it's a percentage. You have to pay sales tax, it's a percentage. You buy things on a discount, it's a percentage. Percents are everywhere. Number 4, 10-pound bag of dog food with a sales tax of 6% included costs, sales tax of 6% included costs of total. Okay, costs a grand total. So when you picked that bag of dog food off the shelf, the price was not $15.90. The price is $15.90 at the cashier because the cashier is charging you the 6% sales tax. Okay, so I know it's a 6% sales tax. The normal price of the dog food, I don't know. What about the increase in price? I don't know that either. Yikes. I've got 2 blanks missing. These are the tricky ones. Put a variable right here. X. Don't you multiply 0.06 times the regular price, 0.06x. Doesn't that give you the increase in price? The sales tax? Yeah? Okay. So now 0.06 times the regular price gives me the sales tax. Here's the regular price and there's the tax. If you add the shelf price, the regular price, plus the tax, 1x plus 0.06x is 10.6x. And don't you get $15.90, what you have to pay? Yeah? There's an equation. Very easy to solve. $15.90 divided by 1.06x. Some people might say, well, if you're adding sales tax onto it, why couldn't you just simply take 0.06 times that and subtract off? Does not work. Does not work. Okay? You've got to do it this way. Here's the average or normal price. We don't know what that is. There's the sales tax. Add the two together. Set it to your total, and it'll work. Okay? Please remember the formula. This formula on percentages is critical, okay? All right. We're going to get into, oh yes, rate, time, and distance problems. I love those. Okay. Let's go down through. We're just going to set these up once again. Now, when you're doing a rate, time, and distance problem, you have so much information. You have different speeds. You have different times. You have distances. I think it's very helpful to do a chart. Okay? If you do a chart, rate times time equals distance. It'll help you keep your information different information. It'll help keep it sorted. We have Sandra and we have Tom. Okay? Sandra starts from Eastville, drives toward Westville at 50 miles an hour. Okay? Tom starts from Westville and drives toward Eastville at 60. The two people are coming toward each other. Yeah? Okay. They both start at 9 o'clock a.m., so nobody has a head start. Since no one has a head start, would you agree with me that the times will both be the same, X and X? Now, somebody had a head start. If Sandra had an hour head start, she'd have an hour more on the highway. Her time, if this is X, he would have an hour less. I'll say that again. If Sandra had an hour head start, her time on the highway would be an hour more than his. You'd have to do X and X minus 1 for him. Or you could do X for Tom and X plus 1 for her. Okay? Rate times time is your distance. So Sandra's distance is 50x. Tom's distance is 60x. Here they come toward each other. When they meet in the middle, his distance and her distance will add up to the total. You can simply add those two up and set it equal to 495. Okay? Really easy to solve. Number 6, another rate, time, and distance problem. Let's make another chart. So I have, I'm kind of, sorry, messed up my chart. I have rate times time equals distance. Okay. Tandy drives from home to the beach at an unknown rate of speed, and it takes her 4 hours. So that's Tandy going to the beach. Okay? Now, she turns around and comes back home. So she returns. So we're coming from the beach to home. She drives home 15 miles an hour faster than what she drove getting there. 15 miles an hour faster. I hope you can read my printing in my small chart. Yeah, I think you can. Okay? And because she drove home faster, she gets home in 3 hours. If you follow this method, you will not have any trouble at all. Multiply straight across. 4x. Distributed property. When you multiply, take the 3 into both parts. 3x plus 3 times 15, 45. What is true about Tandy if she drives to the beach and comes back home from the beach? What's true about the distance when you go from home to the beach and turn around and come back home again? Aren't the distances equal? Right? So just set that one equal to that one. The 4x equal to the 3x plus 45. Okay. Number 7, another rate, time, and distance problem. So I have rate times time equals distance. I have Trent gets mad at his family, runs away from home. Dad comes to try to catch him. Okay? He leaves home at 9 o'clock at night, driving at 60 miles per hour. Dad leaves home at 9:30, traveling at 70 miles per hour. Now, this is what I just talked to you about before. Trent has got a half an hour head start, right? Because we are doing miles per hour, because we're working an hour for the speed, you couldn't say he has a 30-minute head start. You got to stay with hours. Everybody catch it. I'll say it again. This is miles per hour, so your time has to be in hours. So Trent's time, I don't know. I don't know how long he's on the road until he gets caught, okay? But I do know he has a half an hour head start. He is on the road a half an hour more than Dad. So Dad's time would be T minus a half. Yeah? Okay, multiply straight across. 60T, take the 70 into both parts. 70T minus half of 70 is 35. Now, what is true when you're running after somebody to catch them? When you're running after somebody to catch them, once you catch them, like two runners in a race, when the guy in second place catches up to the first guy, haven't they run the same distance, right? Okay, simply set Trent's distance equal to Dad's distance when he's caught. And you can solve for the time. It'll tell you how long it takes Dad to catch him, okay? Rate, time, and distance problems, make sure you do a chart, okay? All right, oh, aren't these great? Yeah. Okay, so I think that's it. All right, so I've got one more kind of problem to show you. These are going to be age charts. Here's Sally's age, her younger brother's age, Celeste, Harry, okay? And you, once again, get a heck of a lot of information. I think it's so much easier if you make a chart. So let's look at number 8. So we are going to make a chart. We have two people. We have Sally and we have Adam. And we are comparing their ages now and in the future. So we have present and future. Sally is 12. Adam is 4. In how many years will Sally be twice as old? Yada, yada, yada. Don't even worry about that. In how many years? We're going a certain number of years into the future. Okay? If I were to ask you right now, how old would you be 5 years from now? Don't you simply add 5 on to what your age is right now? Okay? So we don't know how many years we're going into the future. Because we don't know, we're going to have to use a variable. So Sally, how old will she be in the future? I don't know. I want to add X, years in the future to hers, and Adam, I will add X also. Okay? So now I have the box all set up. In how many years will Sally's age stop? In how many years will, in the future, how many years into the future will Sally's age be? Sally's age, 12 plus X, equal twice Adam's. Twice times 4 plus X. Think about that. Now, people get screwed up in these because they don't do what it says. When you're going in the future, you just add years on. The twicing action has nothing to do with that. When you go to set up your equation, in the future, how many years Sally's age will equal twice Adam's? And it's easy to solve. Number 9, a chart here. We have Celeste and her brother Harry. I think once again we are in the present and the future. Okay? Now this time, we don't know how old they are right now. And the key is, who do you know the least about? I know something about Celeste. She's 3 times as old as Harry. Harry beats me. I don't know anything about Harry. H for Harry. Celeste is 3 times as old as Harry. So it's going to be 3H. Yeah? Okay? In 5 years. We know how many years to add on. We're going to add 5. 3H plus 5. H plus 5. In 5 years, the sum. Sum means to add. You add these up. 4H plus 10 will equal 82. You see what I mean about being easy to solve? These are incredibly easy to solve but they're tricky to set up. Okay, number 10. I tried to make a tricky one. I don't know if I succeeded or not. So number 10, we have Tony and a younger sister. All right, so here we go again. Age chart. So we have Tony and sister. Is it present and future again? Yep, present, future. Tony's 18. Bingo, got it. His younger sister's age is unknown. I don't know. X. In 6 years, stop. Don't even read the rest of the problem. In 6 years into the future, simply add 6. 24 and x plus 6. Everybody with me on this? Okay. You simply add 4 or 6 years on to both of them. 6 plus 18 is 24 and x plus 6. Now we've got the chart all set up. Let's read the rest of the problem. In 6 years, Tony's age. In 6 years, Tony's age, 24, will be equals twice his younger sister, twice the x plus 6. Okay? I love these problems. It's one of the first homework assignments in this class that you really have to think about what you're doing. Okay? Enjoy, enjoy, enjoy. You're going to have fun with these.